Right. So, continuing on the review of this book from chapter 7, Black Holes Are Not So Black. I've been just notified that this room I don't have it for much longer, so I need to finish the review. In chapter 8, Sir Stephen Hawking explains origin and fate of the universe, and that is a very fascinating chapter to read, in which he explains in a realistic example of our planet Earth, how our universe started with a big bang. So as you know, the the map of Earth, as we have a north pole on the top, south pole on the bottom, and equator in between. And similarly, Sir Stephen Hawking, he explained where is north pole. He said the start of big bang, and that is the point where big bang started and the universe started to expand, and where the normal equator line in Earth, that is the maximum expansion of the universe. And then we have imaginary time, where the universe keeps on contracting again towards its final fate, which is the big crunch. So in chapter 8, he gave a very good examples what triggered the start of the universe and how it's gonna end. Chapter 9 is the one of my favorite chapter in this book. It's called The Arrow of Time. So basically, it's a fascinating concept which we use every day. So Sir Stephen Hawking gave us example of entropy. Entropy is a measure of disorder in a system, and he says that by the very nature of time is always moving in one direction, which is from past to present to future. And he mixed this phenomena with the entropy phenomena, second law of thermodynamics, that the system disorder will always gonna be increase, and the total entropy of two individual systems will always be more than the entropies of individual systems. So Arrow of Time is a glorious chapter in my opinion. It gives you a clear idea of the origins of the time, why time is moving in one dimension, and what's the future of the time is, as the future of the black holes, stars, everything is going to end. Similarly, we have the final time when the time is going to end. Chapter 10 focuses on wormholes and time travel. That is a fascinating topic for lots of Hollywood directors. One of my favorite movie, Back to the Future, also based on this fascinating idea. In this book, chapter 10, Sir Stephen Hawking, he explained with a very poetic way, there was a young lady of white who traveled much faster than light. She departs one day in a relative way and arrived on the previous night. So in itself, he admits that it's impossible that we can go to past. I mean, there is no way we can go to past because of the very nature of arrow of time, which he explained before. And that is another magical effect of the great writer, that he first builds on the logical ideas, then he gives you his own logic, powerful logic, that why the time is moving in the one direction. Same time, he took the concept from Einstein, which he explained that the speed of light is constant in our universe and nothing can travel faster than speed of light. In this chapter, Sir Stephen Hawking, he gives the example of CERN, that we can achieve the speed of small particles to close to 99.9% of the speed of light, but still we cannot cross the light barrier. So it's technically impossible. So in this chapter is Sir Stephen Hawking explains the birth of wormholes, which is a shortcut distant um, parts of the universe. If I give you a quick explanation, so if we say this is the universe, and what is a wormhole? Wormhole is between this point and this point, a shortcut, which is a highly curled up dimension which exists virtually, which is a shortcut. Otherwise, if you want to travel, you travel from here to here. You have to travel all this distance. So he explained this magically in this chapter 10, the wormhole and time travel. And he explains why the direction of time is one way. Chapter 11 talks on the unification of physics, and that is, I think, the final chapter in which Sir Stephen Hawking finally explains the future of the physics, which is linked with quantum mechanics and string theory. That is, that we are all made up of small tiny strings, which are consists of quarks, 6 flavors of quarks, and there are open loop strings, closed loop strings, and it's that he gives the examples of how in a four-dimensional world, space-time, we can merge quantum mechanics with general relativity. So this marriage of quantum mechanics and general relativity gives us more finite spectrum of space-time with a defined discrete boundaries. So finally, chapter 12 talks about the conclusion of this book, in which he explained the scientific laws of previous philosophers and how they reached on the point of general relativity, which Einstein discovered. And after Einstein, quantum mechanics, which is the phenomena, merged with general relativity, and it gives us the finite space-time boundary. So there is no boundary. That is the explanation of quantum mechanics and general relativity. So overall, my experience of this book is wonderful. I really loved it, and I strongly recommend everyone, every science lover, every person who is doing his research in physics, or even if you are not linked to education or academia, still for fun you can read this book. It's only going to increase your understanding about time, why we think in a certain way, and what is the future of the universe. So my marks for this book, I mean, I'm giving my review on one of the best writer we have. I would say 10 by 10. It's a fascinating book to read, and it has helped me and my own understanding of time and space. It's very nice. Thank you very much.